If the group's average weight loss is different, if it's due to coincidence, this is called natural variability. And we've seen these vocab words actually on day 1 of stats. But if the weight loss is different, it might also be due to the treatment, and that's the induced variability. And then, weirdly enough, just based on the way this is organized, we're going to do this later. So we're going to piggyback on this. Oh, shoot, I don't have data for my weight loss example. Well, that was a bust. We immediately switch gears. But that's the idea of what we're doing. This actual data that we're going to run the simulation with is with seeds and growing plants. So a seed company is trying to determine the effect of synthetic nutrients versus organic nutrients. So they select 40 seeds and randomly distribute the seeds into 2 groups of 20. 20 organic, 20 synthetic. And so they give these plants these different nutrients. And after 3 weeks, they check out each plant's growth, measured in centimeters. So here are the first groups, and here's the second groups. So in our simulator, we actually have to enter the data. So I'm going to jump to the simulator, which is on my website, and you have to actually type in the numbers, which is a little bit more tedious. You might not want to do this on your cell phone. I know some of you have been doing them. So 6, 8, I'm just typing in group 1, 13, 14, 16, 16. Tell me if I did something wrong because I'm not looking. 20, 20, 22, 25. And then I have to hit add. So you might want to take a quick look at them to make sure you didn't mistype a number. And then sample B is my synthetic. 11, 12, 12, 15, 15, 15, 16, 17, 18. Yeah. Okay. Those all look good. All right. So I want to I'm gonna do the box plot later. I'm gonna jump right into this new concept of comparing sample means. So I want to run 100 simulations and run. Okay. So this is showing us the difference in the sample means. So 0 would mean that there was no difference between the 2 groups. And let me just see here. I'm going to assume they're taking the synthetic average and subtracting the organic average. So when they do this the first time, I still have to set the stage a little bit. Maybe we should go through this in the proper sequence. We'll come back to that. Let's do the box and whisker plot to actually see what did actually happen. So, did anyone do this already? I saw some people crunching numbers into their calculator. No? So we go to our list, stat, edit your lists, clear everything out, type in your organic numbers, 6, 8. Into list 1. And then I'm going to crunch my numbers on that. So stat, calc. Okay, so group 1, which is organic, had an average of 15.15 centimeters grown. And for their box and whisker plot, the minimum was 6. 12 is their Q1, 15 was their median, 18 was their upper, and 25 was their highest. So this is the organic. And then enter, I'm going to keep the list on, I'm just going to do L2 for my second and enter all those. So stat, calc, one variable statistics, but now I'm doing list 2. And I'm calculating those numbers. So that had an average growth rate of 17.45. So my min is 9, 15, 18, 20, and 28. Okay, here we are. Preliminary results. Which group, Kaylee M, does it appear did better? The second group. By 2.3, right? The difference between them. And down at the bottom, they want find the observed difference in the sample means. So the observed difference was 2.3 centimeters. The synthetic nutrients did better by nutrient-fed plants. Now, that doesn't mean, though, that some in the organic, look at your highest organic growth plant, 25 centimeters, that way outperformed the lowest synthetic growth. So obviously there's some natural variability also playing into this. But on the whole, the synthetically fed plants did better, it seems. Now the question is 2 centimeters on average significant enough? Raise your hand if you think it is. What does your gut tell you? Nate says yes. I would say 2 centimeters is probably 2, but I would then say that the majority of you don't think that's enough or just don't care. Okay, so what the simulation is going to do, and this is where you have to kind of wrap your head around it. Knowing what actually happened in this difference of 2.3 centimeters, what the simulator is going to do is it's going to take those 40 plants and it's going to reshuffle them. And so what it's going to see is now, it already knows how they grew. It's going to reshuffle them and put them in different groups of 20, 100 different times. And look at what the difference between the averages is when they truly are randomly now post-observation, what the result is when they're randomly thrown into groups. Okay? So, I'll go back to this. And I'm trying to think what it's subtracting from what. I don't really have much to look at, and it doesn't tell us. I'm going to say, this says x2 minus x1. So it's taking our synthetic average and subtracting our organic average. So it's splitting it into groups, and the first time, the difference between the averages was negative 4.3, which means group 2 minus group 1 led you to negative 4.3. So they were off by that many centimeters. And that is over here on your histogram. And then negative 3.4, and that's right there. So all the way up to sometimes when they were randomly shuffled, on the high end, the second group minus the first group had a difference of 3.5. So that would insinuate that 3.5 centimeters taller, this one would be 4.3 centimeters shorter, and so on. So what we would look at when we do this is where does our difference fall? We were at a positive 2.3, which is out here. What percent of them were positive 2.3 or more? How many? 3 3 out of 100, 3%. So 3% of the time, this happened due to coincidence of how they were grouped, which means 97% chance that the difference that we are seeing with these plants is due to the nutrients. Do you follow? Okay? So now I'm going to guess we have to write that. So run the program mean comp with 100 simulations. Use your calculator to create a frequency. We saw all of that. So look at the data list. We did that. What percent of the differences were at or above the 2.3? We said 3%. So now, how confident are we that the observed difference is due to the induced variability? So I'm going to write a couple things. There is approximately a 3% chance that the difference in height is due to coincidence. AKA, that would be your natural variability, which means there is approximately a 97% chance that the difference is due to the nutrient treatment. Either or, both of those sentences are fine. You don't necessarily need both. I'm just trying to give you the complete picture by writing both. Does that make sense? Okay? So again, it's all about where does your result fall on that histogram distribution and coming up with a percentage of the time that happened by chance. Any questions? Yep, go ahead, Nathan. Right. And you're seeing that over and over again with your histograms. The further out it is, the more likely that there's a reason behind it, and it was not due to sheer coincidence. Okay, things that happen in here are, pretty likely that they just happen naturally by, the group that you happen to get thrown into. But the further out you are, the more of a chance it's due to a cause. And again, with stats, you could never say 100%, but you become more and more confident. It's pretty likely that there was a cause and effect relationship. Here, it's very likely that there's a cause and effect relationship. If you're in the middle, it's very likely that this was due to coincidence. Okay, so we use those non-absolute terms, but like you kind of give a strength of opinion sort of with likely versus very likely. And the further out you are, the more you can use like very likely, or it's extremely likely that these nutrients caused that difference. Okie doke? Okay? Alright, so that just one example on that. And go back to the front. We're just going to look at some of these. Review. Use this as an opportunity because you can only do so many of those long-winded examples because they take so long to wrap your head around. So, take a minute on this first one. Which of the following will have the smallest standard deviation? A sampling distribution of sample means for sample sizes. So, if your sample size is 15 people versus 100 people, what causes a smaller standard deviation? What causes smaller variation? A smaller sample size or a bigger sample size, Nate? Very good. The more people you sample, the less your variation is going to be. Okay? Explain the difference between the sample mean and the mean of the sampling distribution. Ugh, okay. The sample mean is just when you take a sample, it's the average of that sample. The mean of the sampling distribution. I don't even know what that is. Who wrote this question? That doesn't look like a Regents question. Nathan Henry, I'm curious to see your thoughts on this one. You're going to have to help us all out. Oh, yeah, I know. This is a doozy of a unit. The average of the sampling distribution. I'm wondering if obviously we're not going to get too caught up on it because if I'm confused, I'm wondering if it's the average of all of these. This is our sampling distribution. If I averaged all of those up, if it would be that. I'd have to go back and even look where I got this question from to try to figure out what this person was getting at. So let's just ignore that one. Don't worry, if I can't answer it, you don't have to answer it. I had to write myself a note next year to get rid of that question. Number 3, suppose you are interested in knowing how many text messages 11th graders send daily. Describe the steps that you would take to estimate the mean number of text messages per day sent by all 11th graders at a school. So this is kind of more introductory stuff that we did earlier this unit. How would you, assuming that you can't ask every single 11th grader to tell you the number of texts they sent in a day, what method would you use? Let's go with Grace. So be more specific. You would go out, what would be your first step? If you wanted to find out, don't look too much into the question. Just pretend like this was your science experiment. What would you do first if you wanted to find out a good estimate for the average number of texts 11th graders send in a day? Would you ask Nate? Nate, how many text messages did you send yesterday? Okay, a number of people. Very good. How many would you start with? Just pick. 50 people. Okay. Where would you get those 50 people? Okay, and to be honest, in an explanation, you don't have to go any more in depth than that. Just use the word. I would, randomly sample, unless they ask you to be specific about how would you get a random sample. You don't have to go into that detail. Good. So you'd randomly select 50. You'd ask them how many text messages they all sent, and then what would you do, Grace? Average them together. I'm going to make up a number. You got 120. Then what? Is that where you would stop? Is that what you would report back? Hamburg juniors, on average, send 120 text messages per day? Okay, so now someone help her out. What would she do next? Because so far, so good. Isaiah? Right. Very good, yes. So you want to somehow mention that you're going to repeat this exercise a number of times, 5 times, 10 times. You don't even need to be specific about the number of times if you don't want to. And then average all those averages. Okay? All right? And last one here, we have 62 random samples based on 10 student responses to the question, how many text messages? So there we go. So this person grabbed 10 people, averaged those 10, and did it 62 different times. Does that make sense compared to what Grace? Draw a dot plot. So essentially, we're not going to do this all out, but it looks like the lowest is 65. So we might do 60, 70, 80, 90, 100, 110. And then 65 would get a dot, 68 would get a dot, 76 would get a dot, another 76, and your, oops, I'm sorry, I'm not showing it. Your dots would start growing. 78 would get a dot, 82, 83, 83, 85, 86, 87, and they just stack up to each other, okay? Based on your dot plot, would you be surprised if your actual average number was 91.7? So let's pretend our dot plot looks like that. If 91.7 is here, and let's pretend your dot plot looked like that, would you be surprised? No. But if it was something way out here, would you be surprised? Yes. Okay, so again, that concept of the further on the outskirts of your curve that you are, the more surprised